Now we're going to do a definite integral, and that's the integral from 1 to e of ln x over x squared dx. And we're going to use integration, and we're going to need to use integration by parts to solve this integral. Now, whenever you have a ln in an integral, and you're doing integration by parts, you pretty much always need to make the ln x equal to the u, because the du is going to be dx over x. If I would make the ln x equal to the dv, then finding the v is all complicated because that sounds so obvious, but this is obvious. Anyway, not that it's impossible. We've actually integrated ln x in a previous problem, but usually this works out a lot easier. Anyway, dv is now equal to dx over x squared. That's my dx. That's my dx squared. So I have my u dv. That's my u up there. My dv over here. Now, du is dx over x, v is negative 1 over x. I want you to figure out where that comes from. That's using the power rule of antiderivatives. And now I have my uv winds up being negative ln x over x minus the integral of v du. There's a double negative, that's why that became a plus, and that's just dx over x squared. Why x squared? Because taking that x times that x gives me the x squared, and that negative is what's going to make the double negative for this. So this gives us negative ln x over x minus 1 over x evaluated between 1 and e. And that becomes, again, what I do is I plug e in over here to this expression, plug 1 in over here to the same expression for x, subtract the 2, and I get negative 2 over e plus 1. I'll let you work out how crunch that all out. That's what you're going to get. Now, this actually is going to be a positive number because, well, e is bigger than 2, so this is going to be less than 1 plus 1. It's going to be a positive number. It's going to be around 2.6. Anyway, what does this look like geometrically or graphically or whatever the word is? It means that if I have the curve y equals ln x over x squared, which is this curve right here, the area under the curve between x equals 1 and x equals e, this shaded area, is going to be equal to negative 2 over e plus 1, which comes out to approximately 0.2642. So again, this problem really had two skills in it. It had the skill of dealing with a definite integral, had the skill of doing integration by parts, and down here we just showed graphically what the problem would wind up really looking like. That's really what we mean when we evaluate a definite integral. We're talking about the area under the curve, or I should say between the curve and the x-axis.